In this lesson, I'm going to show you how to do the long division and also try the same question using the comparing the coefficient method. Okay, so to do that, I'm going to use the factor theorem. So the factor theorem tells me that if you have a polynomial p over x, and if when you put a number a in the expression and the remainder comes out as a 0, then x minus a is a factor. Of the polynomial p of x. So I'm going to use that to find the first factor that will divide into x cubed plus 2x squared minus 29x minus 30. Okay. In this lesson, I'm going to show you how to do algebraic long division and comparing the coefficient method. First, I'm going to do trial and error and put numbers in until I find the this expression equals to 0. So 1 cubed plus 2 times 1 squared minus 29 times 1 minus 30. Clearly that's not going to give me 0. So I know that x minus 1 is not a factor of this line. Okay. Next I'm going to try minus 1. You need to be systematic. So I'm going to do minus 1 cubed plus 2 times minus 1 squared minus 29 times minus 1 minus 30. So minus 1 cubed means minus 1 times minus 1, that's positive 1, times another minus 1, so the result will be minus 1. Minus 1 squared will be positive 1, so 2 times positive 1 is 2. Minus 29 times minus 1 is plus 29 minus 30. This time result will be 0. So now I can say that x plus 1 is a factor of this expression. So now I'm going to do the long division. We just found that the x plus 1 is a factor of x cubed plus 2x squared minus 29x minus 30. So now we're going to start the long division. So here your target to make is x cubed. You need to multiply this x times this expression to make x cubed. So I know that x times x squared will give me x cubed. So I'm going to write x squared on the roof of the bus stop, and then I'm going to verify it by x times x squared. So that's x cubed, write it underneath. And then I'm going to do 1 times x squared is x squared. I'm going to find the remainder by subtracting. So I'm going to have x cubed, to take away x cubed, that's nothing. And 2x squared minus x squared is x squared. I need 2 terms, so I'm going to bring this expression down here. And then I'm going to write minus 29x. Now, my target to make is x squared. I need to multiply this x with something so that I can make x squared. So I know that x times x give me x squared, so I put plus x. So x times x is x squared. I write my x squared here. Next, 1 times x is x. So plus x. I need to find the remainder, so to subtract x squared, take away x squared, nothing. Minus 29x minus another x, that's minus 30x, and I need to bring this minus 30 down here, so that's minus 30. Next, my target to make is minus 30x. X times something got to be minus 30x. So I know that's minus 30. And I need to write this down. So x times minus 30, minus 30x. 1 times minus 30, minus 30. When you subtract, remainder 0. Now, I need to factorize the quadratic. So I will have 1, 2, 3 linear expressions. Now you're going to factorize the quadratic you just found. So the first thing you're going to do is write out the question and then write the whole thing as linear times the quadratic you just found. In the next stage, you're going to factorize x squared plus x minus 30. Now, this one is quite easy because the coefficient of x squared term is 1. So all you have to do is find the two numbers. When multiplied together, make minus 30. When you add them together, make plus 1. Okay. So it's x plus 1 as it is. Next one, you can just write x and x. And two numbers multiplied together make minus 30. So I can say that's either minus 6 times 5 or 6 times minus 5. But I want plus 1 when you add them together. So that must be plus 6 and minus 5. So you just factorized the cubic. Now the second part of the question says, find the roots of the equation of x cubed plus 2x squared minus 29x minus 30. So I can do this must equals to 0. So x plus 1 times x plus 6 times x minus 5 equals to 0. Okay, so 0 times anything will give me 0. So I'm going to find the value of x that makes this part equals to 0. So x plus 1 must be 0. Therefore, x must be minus 1. Now I'm going to do the same thing for the second part and the last part. So x plus 6 has to be 0. So x must be minus 6. X minus 5 must be 0. So x must be 5. Okay, so my solutions are minus 1, minus 6, and 5. This time I'm going to show you how to factorize the cubic using the comparing the coefficient method. First thing you're going to do is write out the question and then make it equals to first factor you just found by using the factor theorem. So this part is exactly the same as the long division. By trial and error, you're going to find the first factor. And because this is a cubic, it's got to be linear times the quadratic. That's how you make the power of 3. Okay, so power of x is 1 here and power of x is 2 here. So that's how you make this 3. Now you're going to multiply out this part, okay, and then you're going to compare the coefficient. So for this, I'm going to draw a grid. So make a grid and times sign here. This will go on the column side, x plus 1, and horizontally I put a x squared plus bx plus c. Okay, A, B, C are just numbers. Now I'm going to do x times ax squared and the right answer here. So x times ax squared, ax cubed. Then x times plus bx, so that will give me plus bx squared, bx cubed. Next, c times x plus cx. Now I'm going to do 1 times ax squared. So that's plus ax squared, and 1 here times bx, so plus bx, and plus c. 1 times c is c. Now I'm going to collect the like terms. So ax cubed doesn't have any other x cubed term, but ax squared and bx squared, they are like terms, so I know I can put them together. Also, bx and cx terms, they are like terms, so they can be together. Constant c is just a number at the end. Okay, so now I'm going to write the whole thing. So I can say that x cubed plus 2x squared minus 29x minus 30 must equals to ax cubed plus, I'm going to do this part now, so a plus b x squared plus c plus b x term plus c. Okay, so I can say the number in front of x cubed term is 1, and that's got to equal to the number in front of x cubed term over here. So 1 must be a. So I'm going to write that down. A equals 1. Next, the easiest one to look at is minus 30 at the end, which is a constant, and a constant term on the right hand side is c. So c must equal to minus 30. So c equals to minus 30. Next, I'm going to compare the coefficient of x squared terms. So that's 2, and that must equal to a plus b. So I'm going to write a plus b must equal to 2, but I know that a is 1 from the previous working, so 1 plus b is 2. That means b is 2 minus 1, which is 1. Now you're going to write the question out, and you're going to say that must equal to the linear factor which you just found times the quadratic. And all you have to do is factorize the quadratic.